Alright, so you guys, the Rolle came up with that theorem, Rolle's theorem, and then mathematicians started playing around with that, and came up with this one, which is much more useful. Well, I shouldn't say much more useful, but I don't know what I will say. I'll just say it's called the mean value. Or you could call it the average value. Right? In math, mean means average. The average value theorem, it only has two hypotheses. F has to be continuous on the closed interval a to b and differentiable on the open interval a to b. If that's true, then somewhere in between a and b, the first derivative equals the average rate of change. And this one's on page 214 in your book. And then they give a few little examples here. All right, here's a continuous function. Right. We found the average rate of change, that's just the slope of the secant line from here to here. We can draw a tangent line over here somewhere, and these two lines are parallel. All right, here's an example where if we draw the average rate of change, there's two tangent lines are the same. They have the same slope. So if a function's continuous and differentiable, then somewhere in between 2 points, the average rate of change equals the instantaneous rate of change. They call it the average or mean value theorem. Is this making sense? When George went to Alpha? I remember when we interviewed him, we hired him to teach. He was a bartender at Alpha. 12 years ago. Maybe it might have been 10. I have to ask him how long. Alright, so could we find, or here what that can we? We're going to find all the values of C that satisfy the mean value theorem for f of x is x times x squared minus x minus 2. For this, the first thing I would do is actually multiply this out. Right, distribute the x, so we get x cubed minus x squared minus 2x. So there's our function. We're going to go from -1 to 1. The mean value theorem says if this function's continuous, and it is, and if it's differentiable, and it is, because polynomials are always continuous and differentiable, then there's some value for x in between -1 and 1 where the average rate of change equals the instantaneous rate of change. So if I take the first derivative, I'll get 3x squared minus 2x minus 2. Right? That should equal f of 1 minus f of -1 over 1 minus -1. Right? Because that's this right here. This is the average rate of change. This is the instantaneous rate of change. Or the derivative of the tangent line equals, or the slope of the tangent line is the same as the slope of the secant. So we get 3x squared minus 2x minus 2. F of 1, if I plug 1 in here, I get -2. Minus, put in -1, I get 1 minus 1 is -2 plus 2, I get 0. And here 1 minus a -1 is 2. So we've got 3x squared minus 2x minus 2 equals -1. So let's see, I'll add 1 to both sides, get 3x squared minus 2x plus 1. Then I'll go about factoring this. Minus 1.
Minus 1.
Somehow that vertical line popped up. Let's see, this, I could split the middle term, but I know the only way to get 3x squared is to multiply 3x times x. And then we want a -1 here, so I think this is going to be -1 plus 1. right? So that would give me negative 3x plus x is negative 2x and then negative 1. So x could be negative 1/3. Oops. Right, negative 1/3 would make this 0. Or it could be 1. Right, 1 would make that. But then if we look at the theorem here, it says there's some number c in between a and b. They use parentheses, not brackets. So that means we don't include a or b. And on here, a was negative 1, b was 1. One of our answers was 1, so we don't include that. We only use the negative 1 thing. So it's not inclusive of the inputs. And just to illustrate that, if I graph this function here, so if we come in here, we didn't have these nice things when I was your age. It sure is nice to be able to look at these graphs and confirm visually what we're getting out the way. If I do that, I look at the window from negative 1 to 1. I go zoom fit. There's the graph. What we just figured out here is if I draw a secant line from this point here to this point here, we just figured out over here where x is about negative 1/3. I should check my window. Well, I did negative 1 to 1, so negative 1/3 would be about right here. I could draw a tangent line right here that's parallel to that secant.
Parallel is when the slope's the same, right?
Yeah,
That's
maybe that was, no, it's the same thing. The slope of a secant line is the average rate of change.
oh,
Right,
right.
the
So the
slope-
secant line is the average rate, the tangent line is the instantaneous.
Yeah, so this was the average rate of change right here.
Sorry, you said it again, so maybe I got confused, but
And then this is the instantaneous. So a tangent line is your instantaneous rate of change, or your speed. And then this is your average rate of change.